So in this lesson, we're going to look at the volume of common prisms. Now, I'm going to give you three formulas. Really, you have two formulas. I would argue you could reduce it to one formula. You could really reduce it to one formula. But do note that as we go through this section, you will not be given formulas on your block exam, so I would strongly advise you to figure out which strategy works best for you. You can either memorize at least two formulas or memorize the general formula. So volume is just the space that fills a three-dimensional object. So last week we refreshed working with area, so we're going to work with volume in this particular lesson. Volume always is length, width, and height. And example units could be anything that's cubed. So centimeters cubed, meters cubed, cubic feet, cubic yards, etc. So there's anything that's cubed is dealing with a volume. That's you got your three dimensions. In terms of formulas that we're going to work with, I've given you a couple of formulas here. This is a formula that you really need to know, the volume of a rectangular prism. Volume is just length times width times height. Volume of a cylinder is another important one to know, and you'll notice it's pi r squared, which we know is the area of a circle, times the height, or if a cylinder is put lengthwise, your height now would be the length, okay? Now, I would argue you can simplify things even further. And we're going to look at some examples on why this formula is really the best of all of the formulas. Everything else reduces to them. You'll notice here, length times width is the area of a rectangle times height. Here, pi r squared, it's the area of a circle times height. Okay, so you'll notice the general formula for volume is the area of the end shape times whatever the height, or if it's laying on its side, times the length of the object, depending on which perspective you're using. So just a couple things to start. We're going to do a couple of volume conversions, just like we did a few conversions using area. If you remember the area ones, you'll find the volume ones are very intuitive coming from that. So how many cubic inches are there in a cubic foot? Well, we know 1 foot is equal to 12 inches. Okay, so 1 cubic foot, what we're going to do is we're going to cube both sides. So 1 cubed is just 1. Feet cubed leaves me with feet cubed, equals, we're going to cube our 12 inches cubed. Putting that into your calculator, you get 1 foot cubed equals 1728 inches cubed. Okay, and all that comes from is 1 cubic foot would be 1 foot by 1 foot by 1 foot. That's equal to 12 inches by 12 inches by 12 inches. So we're just multiplying the three dimensions together. When all of them are the same, we cube it. Now your calculator probably has a button on it that has an X with a little cubed on it. If you're wanting to look for that cubed button on your calculator, it may look like this, or it could be a second function. Sometimes it will be. Look for this X cubed. The other way you can do it is some calculators have, there's a couple buttons. Some of them have an XY. You could push this, you could use that button. You would do 12, the XY button, and then you're going to press 3. So that is the same as 12 cubed. Oops, that's too many threes there. Okay, so that's the same as 12 cubed. There is one other button that you could see, and some of your calculators will have this caret button, and that will also do an exponent. So you would do 12, the caret button, 3, and equals, and that's going to give you, that's the same, oops, that's the same as putting in 12 cubed. Okay, so it is good to know how to use that cubic. These are conversions that won't be given to you on block exam. So I like to memorize that to go from inches to cubic inches, to take those conversions. I just cube everything in the conversion because I can remember all the linear ones easy, but memorizing the cubic conversions, well, my memory only holds so much. We'll just put it that way. The memory only holds so much. So the next one, how many cubic centimeters are in a cubic meter? So, well, we know 1 meter is equal to 100 centimeters. So we're going to do the same thing as before. So 1 cubed is still 1, so 1 meter cubed is equal to 100 cubed centimeters cubed, which is equal to, let's see, we need 100 times 100 times 100 leaves you 6 zeros. So that leaves us with 1,000,000 centimeters cubed. Just pretty easy to do. And the last one, if there's 3.28 feet in a meter, how many cubic feet are in a cubic meter? So you know, well, 1 meter, it just says, is 3.28 feet. So that must mean 1 meter cubed is equal to 3.28 cubed feet cubed. Plugging that into our calculator, 3.28 cubed leaves me with 35.3 feet cubed. Again, pretty easy questions to do. Now a couple of practice questions. So we're going to start with rectangular prism volume. Determine the volume of oil in a rectangular tank with a length of 1.2 meters, a width of 0.75 meters, and a depth of 0.25 meters. Give your volume in liters. So, and they've given you a conversion that 1 meter cubed equals 1,000 liters. So that means we should figure out our volume in meters cubed. So how do we do that? Well, volume is equal to length times width times height. How do we know that? Well, it says it's rectangular. I would suggest sometimes it can be useful to do a little sketch for these ones, depending on how good your artistry is. So we have 1.2 meters, 0.25 meters, and 0.75. So if you need to make a sketch, sometimes that can help you visualize what it looks like. Length times width times height leaves us with 1.2 times 0.75 times 0.25. Multiplying all three of those together, we end up with, it would help if I kept the page with those up. There we go. Let's erase what I just started, or start to copy the wrong answer down. All right. You get 0.225 meters cubed. How many liters is that equal to? Well, we use our conversion. 0.225 meters cubed times, well, we know that 1 cubic meter, we want to cancel meters out, so meters is here, so we're going to put meters on the bottom, times 1,000 liters is equal to 225 liters. Okay. I guess that would be similar to partial fill in an oil tank. So I think that would, dimension-wise, work out relatively similar. I'm just thinking of the dimensions of my tank in the basement, though I don't know that we'd be 0.75 meters wide. Maybe it would definitely be under that on the inside at least. All right, so easy calculation. This is a really good calculation. We're looking at ventilation. A bathroom measuring 12 feet by 8 feet with 8-foot ceilings has a fan rated for 100 CFM or cubic feet per minute. If the fan runs for 15 minutes, how many times will the air be changed in the bathroom? So this is actually a two-step question. First of all, we need to know, well, the fan runs for 100 cubic feet per minute. So that means I need to know that how much air is in the bathroom in cubic feet. So first of all, the volume of the bathroom. That's 12 by 8 by 8. Leaves us with 768 cubic feet. Now we want to know, okay, that's how much air is in the bathroom. In 15 minutes, how much air can that fan move? So how much air in 15 minutes? Well, it moves 100 cubic feet per minute. Just another way of writing CFM times 15 minutes means we're moving 1,500 cubic feet. Okay, we can move 1,500 cubic feet in 15 minutes. Well, how many bathrooms fit inside of that? 1,500 divided by the size of the bathroom gives us 1.95, or approximately 2 times. So the air will be changed in there approximately twice. If you have a bathroom that's getting overly steamy with too much condensation, increasing the size of the fan will change the air out more often. The other thing is to shut a bathroom door will help evacuate the steam faster because you're only evacuating the air from that room as opposed to looking at a larger space, because when the door is open, we're open to an adjoining space, so we'd actually have a larger volume of air that we're drawing from. Little things that sometimes I think about, and I guess I think about it more. If you notice the mirror steaming up, and this time of year I notice sometimes we get a little bit more condensation on the walls than in the summertime, and I think that has primarily to do with needing more insulation on the exterior of our house. But yeah, one of those things with how long do you leave the fan on in order to evacuate all that moist air in the bathroom. All right. Next, we're going to look at cylindrical prism volume. So a cylindrical prism is just anything that's a cylinder. Okay, so a cylinder shape. Prism just means a three-dimensional shape. So how many cubic feet of air is held by a cylindrical duct with a diameter of 28 inches and a length of 75 inches? So we're dealing with this particular shape, so we first need to find the volume. So our volume is equal to pi r squared times the height. Now, this has a diameter of 28 inches. We need radius for our formula, so the radius is equal to 14 inches. So volume is going to be equal to pi times 14 inches times the height. Height in this case is going to be the same as our length, okay, 75 inches. Putting all of that into your calculator, you will find, let me throw my squared back in there, you will find you get 46,181 inches cubed. But it says how many cubic feet? So let's refresh our conversion. 1 foot is 12 inches. So 1 cubic foot is equal to 12 inches cubed, which is 1728 inches cubed. Okay, so what we need to do in order to find cubic feet, we're going to have to divide this by 1728. Now you can set up the unity fraction if you would like. But we know we're going in this direction, so it has to be a division problem. And in order to get our answer, plugging that into our calculator, we get 26.7 cubic feet. Okay. So we can have a note here if you want to add a note. Height can also be thought of as length. All right, we're going to look at a couple irregular prisms that I'm not giving you the formulas for, and we're going to have to move into this general formula area. So what's the volume of the shape shown in cubic meters, and you're given a linear conversion. So the general formula, it just doesn't fit a rectangle, it doesn't fit a cylinder, so we're going to look at irregular shape, is area of the end times height. So area of this particular end times the height, or in this case, our length, okay? So the area of the end, well, we happen to know that the end here is a trapezoid. So the area of the base is going to be our trapezoid formula, which is big B plus little b divided by 2 times the height of the trapezoid. So we're just looking at this end area. So we're going to have 4 plus 7 divided by 2 times 12. Putting all of that into your calculator, you get 66 square feet. Now volume, we're going to take that area of the base, 66 square feet, and we're going to multiply it by the length of the object. So this would be a great question for, say, let's say this could be a roof. You want to figure out what's the volume of an attic. Okay, oops, I wrote a squared on there, and it's not a square, it's just a linear measurement. Get rid of that. All right, so 66 times 40 leaves us with a volume of 2,640 cubic feet. Now we just need to do a conversion. So we know 1 meter is 3.28, so 1 meter cubed is going to be equal to 3.28 cubed. 3.28 cubed is the same as, do I have it written down? Yeah, I do, 35.3. Okay, so we're going from feet to meters. So again, we're going to divide by our conversion factor, which is 35.3, and we get our volume is equal to 74.8 meters cubed. Now, I hear my husband often go through these conversions by memory. One of the reasons is he's in wastewater treatment. So with wastewater treatment, they're always looking at the volume of either rectangular or cylindrical tanks. And then hose volumes, pump ratings, and all of that. And unfortunately, one of the disadvantages of working in Canada is all of your books, all of the books for his courses come from the US. So everything is in gallons and cubic feet. But because they have to report to the Canadian government, everything has to be reported in concentrations. Usually it's per cubic meter, because if you reported it per liter, there's just such a huge number of liters, and they don't talk about kiloliters. Instead, they switch it to cubic meters. And so he'll go through these conversions all the time, just off the top of his head. So you'll find some of these conversion factors, the more that you use them, if they're part of your regular work, you'll just memorize them, and you won't end up calculating them. That 1728 cubic inches in a cubic foot, that's one that you'll probably have just memorized. I know it's one that Charlie has quoted numerous times to me, and it's just a conversion factor that he's used so many times, he can't forget it. Just kind of like that feet and inches, that you're probably at the point where 1 foot equals 12 inches is just, that's old news. And one last question, what's the volume of this shape shown in cubic meters? So again, we have an irregular shape. Just break it into two simple shapes. So we have a half, so we're going to use this formula again. So I want you to think about the area of the end here. So this area. So we have a half circle plus a square, or this, I shouldn't say a square, it's actually a rectangle. So this is 8 millimeters. So if the width of the rectangle is 7, that means the radius of this is 3.5. So in order to do our calculation, I always like to label things with shapes. So we've got the area of a half circle is going to be half pi 7, oops, not 7.5. Let me just erase that. 3.5. 3.5 squared. So half pi r squared will leave us with 19.2 millimeters squared. The area of the rectangular part is equal to 8 times 7, which is 56 millimeters squared. So base area, or area of the end, is going to be 19.2 plus 56, which leaves us with 75.2 millimeters squared. And now if we want to know the volume, we have 75.2 millimeters squared times 13 millimeters in length. Gives us an area of 978 millimeters cubed. Or I said area, I meant a volume. Volume of 978 millimeters cubed. You could have done this question one other way. You could have said we have half a cylinder stacked on top of a rectangular prism. That should give you exactly the same answer. So if you want to try it that way, go ahead. You can do that for some extra practice. And that finishes off that section. So that gives you a really quick intro to some volume questions. You'll have a few basic questions. You will see volume come back up when we get to dealing with fluids towards the end of our semester. But make sure you understand how to work with those volume formulas, and do watch for conversions along the way.